If you haven't already watched our previous video, Multiple Stars, we recommend you do so before proceeding with this video. When two or more facts describe events that do not take place at the same time, they describe different processes. If they are placed in a single fact table, analysis of the individual processes will be hampered. Placing them in a separate fact tables allows each process to be studied more easily. To understand how this happens, let's see an example. The sales department have the following request: analyze quantity ordered by date, customer and product. Analyze quantity shipped by date, customer and product. These statements identify measurements, facts, in bold text, and context, dimensions, in blue text. Each expresses the lowest level of detail at which the measurement will be studied. Although they share the same dimensionality, the two measurements do not occur at the same time. For example, on days when a customer orders a product, there may not be shipments. Quantity ordered and quantity shipped do not describe the same process. As we saw in the previous video, the final table attempts to address the requirements using a single fact table, sales facts. It contains the facts quantity ordered and quantity shipped. The grain of this fact table require that orders, shipments, or both be recorded by day, product, and customer. This might also be stated as shipments and/or orders. The presence of and/or in a statement of grain is usually a sign of problems to come, as you will see shortly. The first three rows of orders provide a dilemma. What values should be placed in the quantity shipped column? There were no shipments on day 124. Two possibilities are to record null values or to record values of 0. For the time being, assume that a 0 is recorded for quantity shipped when there is an order but no shipment on a particular day. On day 457 and 788, the converse situation exists. Now suppose that some is interested in studying shipments to customer 777, and that they generate a report from this fact table. They might run a simple query to produce a report like this. When a single fact table tracks two or more processes, problems occur when someone is interested in studying only one process. In this case, the process being examined is shipments and the problem is evident in the final row of the report. Although product 333 has not shipped during the report period, it appears on the report with a quantity shipped of 0. A typical report might be much larger, continuing numerous zeros scattered throughout. This can be very confusing to end users, who will rightly ask, why is product 333 showing up on this report? We did not ship product 444 either, and I don't see that one on the report. What gives? The appearance of product 333 on this report is easily explained. It is there because the customer ordered it during the time period in question. This explanation is little consolation to business users trying to analyze shipment data. They are not interested in the fact that orders occurred. To them, these zero-value facts are a perplexing annoyance. The phenomenon of zero-value facts on reports is common when multiple processes are modeled in a single fact table. Notice that the use of null values would not have solved the problem. Product 333 would still appear on the report, only this time with a blank instead of a 0. One might be tempted to try addressing the zero-value result problem at query time rather than schema design time. For example, the query to produce the report might be adjusted to contain a having clause like this. This adjustment to the SQL must be tacked onto every query that studies shipments. A similar clause must be added to every query that focuses on orders. If there is more than one fact associated with each process, it will be necessary to keep track of which clauses to add in each situation. This is an example of bowling the frog. You must already know the story, right? The story, however, illustrates the effect of poor schema design. Each workaround seems small, but their cumulative effect can be unbearable. Schema design time is your chance to boil the frog. A variation of the single fact table solution is to record only one generic fact. A new dimension will determine whether it represents an order or a shipment. This approach solves the zero-valued row problem, because each row is either an order or a shipment. In addition, the query results will show up in an unusual format that will require additional formatting inside reports. This format becomes even more problematic for queries that compare both processes. Information desired in a columnar format will be returned in different rows. Once again, design shortcomings will base suffering among report developers. Rather than come up with other ways to boil the frog, the preferred solution is to model each process in its own fact table. Notice that each fact table shares the common dimension day, product, and customer. Set up in this manner, it is now possible to study the individual process without additional bother. Those seeking information about orders can use order facts. Those seeking information about shipments can use shipment facts. If either of the processes has additional facts, they can be added to the appropriate fact table. Thanks for watching and see you soon.